All right, guys, this next piece is the last bit of the appendix, working with exponents and roots. This is basically what Chapter 7 was in Algebra 2. You did all that stuff with exponents, roots, radicals. It seemed really abstract. It's pretty much just a skills-based thing that it's like putting in the extra time in whatever sport you do or theater or band or whatnot. It's just all that kind of mundane practice stuff that helps you be better at the whole game or your instrument or whatnot. What we're going to end up doing with this stuff is trying to solve equations that look like this. So we got square roots in them, we have x's and different things. So let's start with just a recap of these rules. These are the root rules. So we've looked at some exponent stuff. This is kind of making them smaller. Please get these down in your guys' notes because it's important to understand. So first one's this. Okay, they use a's and n's here. It's just like this. If I ask you to do the square root of 4, that's the same thing as 4 to the 1/2 power. Okay, square roots, there's secret little 2's hidden within there. So it's just how you write it in radical form or in exponent form. And then obviously you'd come out of here and you'd say this is 2. Same idea. If I ask you to do, let's say, cube root of x squared, well, you're going to say this is x to the 2/3 power. Okay, and that's actually coming down here and stealing from the second rule, but it's all the same idea. Okay, if I had you do the smiley face root of x to the 10th, you would say this is x to the 10 over smiley face. Okay, like I said, it comes down here to the second rule. Whatever's on the bottom gets kicked out front. So you can see n's on the bottom here, it gets kicked out front there. So if you had 8 to the 2/3 power, the 3 gets kicked out if you want to put it in radical form. So it looks like this. So this is cube root of 64, and then we can talk about how we simplify those things from there. Okay, last rule down here is you can break different things up. Let's say you had square root of 16x to the 4th. You can break that up this way. And you can handle each piece individually. So your answer would be 4x squared. Okay, let's say you had third root of y squared x to the 6th. You could break this up into y to the 2/3 power. Remember, the 3 is what's going to be on the bottom. Okay, whatever's out front here in the second rule is what's on the bottom, times x to the 6/3, and this would simplify y to the 2/3 x squared. Okay, and we'll work on all that stuff again. Okay, it is a pretty abstract topic, but one of those skill-based things we just need to be good at. All right, so how would we apply these root rules to something like this? And we'll do obviously a lot more of them in class. First is noticing you get a 3 there, not a squared, so we're not doing square roots. 16 has a square root, but there's also a cube root hidden within it. So if you remember our list of cubes, 1 doesn't count because that's not going to do us any good. 125. So this list would be important to have somewhere. 5 cubed, 216 is 6 cubed. Now, how you should split this up is use that last rule and say, okay, what's a number I can actually take a cube of? Okay, well, I'm going to use 8 in there. So I'm going to keep the negative with it, and then I'm going to split this up and do a 2. Okay, because that's how I can get to 16. These two things multiply together. I'm going to keep the x to the 4th like this, and I'm going to handle each piece individually. Cube root of -8 is -2. Now, a neat thing with cubes is you can have negative roots. You can't do that with square roots because you can't square something to get a negative. But if you do -2 cubed, you will get -8. Okay, so you can have negative roots as long as you're in cubes or anything to an odd power, basically. So that's taken care of. Nothing you can do with the cube root of 2. Okay, your smallest cube is 8. Anything smaller, you're kind of out of luck. Now, if you remember from Algebra 2, how we handle this is, think about how many times 3 goes into 4. Pull that out, and your leftovers are left over. So 3 goes into 4 once. So I'm going to pull 1x out of there, and then left over in here is just an x. Okay, so you can think about how many times it goes in evenly and what's left over. So just kind of quickly, another example here over to the side. If you're doing cube root of x to the 8th, 3 goes into 8 twice. So 3 goes into 8 twice evenly. That means you get 2 left over. Okay, if you're doing cube root of z to the 10th, 3 goes into 10 3 times evenly, and you got 1 left over. Okay, it's just kind of a quick little recap of that, and we'll lay all this out in class again, get you guys reacclimated to it. All right, kind of some more simplifying things here. So you get a rational thing here, but it's got square roots in the bottom. It's going to ask you to simplify. In order to be correct in math, you don't really want these square roots left in the bottom. So we did them with complex numbers, and we multiplied by conjugates. It cleared out the i's in the bottom and left you with real numbers. So let's do that same thing here again. Now the conjugate is you only have to change that second piece. The reason we can do this again is because we're multiplying by 1. 9 plus square root of 5, all over 9 plus square root of 5, so we're not changing this at all. So if you do this correctly, this is just like a difference of squares is really what's happening. So you're going to get terms that cancel out on the bottom, which is exactly what you want. So you get 81, you get 9 square roots of 5 minus 9 square roots of 5 and minus 5. It's exactly what we want to happen, just like difference of squares. Those will cancel right out of there. On the top is 9 square roots of 7 plus the square root of 35. You can multiply square roots and have them come out as just the product of those two things. You don't have to leave those separate. You can't add them, but you can multiply. Okay, 35 doesn't have anything in it, so we're going to keep it exactly like that. On the bottom here, we get down to 76. So if you go to your calculator and you plug this in with parentheses on the bottom, and you plug this in, as long as we did everything right, they should be the same number. Okay, so simplify by the conjugates to get stuff out of the bottom. All right, here's something. You got 4th roots over 4th roots. And we want to simplify this. Again, we don't want any of these 4th roots in the bottom. Because these are the same, I'm going to take a little shortcut, and I'm going to write them all over the same 4th root sign. I can only do that if they're both 4th roots. Now I'm going to simplify the stuff in here and see what happens. That'll give me 32, x to the 6th, give me x to the 5th. This will give me y to the -8 if you want to write it like that, or you could put it on the bottom. I'm just going to put it up top so we don't have to deal with anything on the bottom. So we're basically out of the fraction. So again, this is still to the 4th root. Okay, now 4th root things. 2 to the 4th is 16. 3 to the 4th is 81. 4 to the 4th, I think, is 256 already. So these blow up very, very quickly. So now we want to simplify this. We can do the 4 into the 5 and 4 into the -8 just fine. Okay, but let's take care of that 32. So let's split it up into the 4th root of 16 times the fourth root of 2. And then we'll write these other pieces here. So fourth root x to the fifth, fourth root y to the negative 8. Okay, fourth root of 16 is 2. So that's out of here. 4 goes into x to the fifth once. There's 1 left over. So that's gone. 4 goes into negative 8 twice. So we're going to go ahead and we're going to pull a negative 2 out of there. Nothing left over. Okay, what's left? Well, we already got that x in there, and we got a fourth root of 2. So I'm going to go ahead, I'm just going to throw a 2x in there as well. Okay, so that's how you would go ahead and simplify that one. Now, some of you guys might have been wondering why I went ahead and pulled this negative 2 out of here, where before I said you can have negative roots, but only when it's an odd power. So there's this little specific little rule that we're actually not going to get into a ton with it, in that you can take negative roots of even powers, but they should actually come out as absolute values. Right? So if you're getting into the calculus and whatnot, your teacher will hit that with you. We're not going to worry about it a ton right now. If you see something like this with variables, let's go ahead and just pull those out as negatives. If you see something like this, though, like fourth root of negative 16, okay, we know 2 to the fourth is positive 16, but there's no way you can do, I mean, if you think this is negative 2, you're trying to say negative 2 to the fourth. You have 4 negatives. Okay, there's no way that's going to come out as a negative. So let's go ahead and make the rule. We'll do it with variables, because those are a little bit different. But with numbers, you can't take fourth roots or sixth roots of evens. So let's try and summarize what we just said a little bit. So negative roots of odd numbers are okay. So something like cube root of negative 27 equals negative 3. That will work because negative 3 cubed is negative 27. Negative roots of even powers are okay if variables. So something like fourth root of x to the negative 16th. Okay, 4 goes into negative 16 negative 4 times. We'll let that be okay with variables. Okay, it should be the absolute value, but we're not going to get into that little specific rule. Negative roots of even powers are not okay if it's a number. So you can't do the fourth root of negative 81 and tell me that this is negative 3. And the reason for that, because negative 3 to the fourth is going to be a positive number. A negative times a negative times a negative times a negative. Okay, so there's kind of a recap of some different things. I know it's a boring skills-based thing, but something we do need to work on. In class, we'll look at how those will help us with rational equations. Okay, so we'll see you guys with questions tomorrow.